Hello viewer, you're welcome once again to my channel. In today's tutorial, we're going to learn how to find a limit. So the question of the board says we should find the limit of this function s cubed plus s squared minus s minus 1 all over s squared plus 2s minus 3 as s approaches 1. Please don't forget to subscribe to my channel. Follow me on Facebook at Shabes Online Tutorial. Like, comment and share my video. So solution. The limit as s approaches 1. Let's say the limit s approaches 1, s cubed plus s squared minus s minus 1 all over s squared plus 2s minus 3. So this is the equation. So in limit as s approaches 1, anywhere we see s here, we are going to replace it with 1. So which is equal to the limit s tends to 1, open my bracket. This is s cubed here, which is 1 cube, then plus s squared, which is 1 square, minus s as s approaches 1, then minus constant 1 all over, this is s squared here, 1 square, plus 2s, which is 1 minus constant 3. So from here now, I can wait further to express it as limit as s approaches 1, 1 cube is also 1, plus 1 square is still 1, minus 1, minus 1 minus 1, which will give me minus 2 all over 1 square is 1, 2 times 1 is also 2, then minus 3. So from here now I can still reduce this as 1 plus 1 is equals to 2, then 2 minus 2 is 0 all over 1 plus 3 is 3, 3 minus 3 is still 0. So 0 divided by 0 is 0. In limit, this is indeterminate. When a limit is 0, no solution is called indeterminate. We are not going to wait further. We are not going to stop at here. We are going to wait further to use. From here now, there are two methods to use. We use the method of long division or L'Hopital rule. So in today we are going to learn how to use L'Hopital rule to solve such a problem when a limit is equals to 0, no answer. So L'Hopital rule, say as this function, we should differentiate this function separately in the sense that the numerator, we differentiate the numerator separately from the denominator. Then we input our 1 because s is approaches 1. So let's see from the question, my limit as s tends to 1, which is equals to s cubed plus s squared minus s minus 1 all over s squared plus 2s minus 3. So in using this L'Hopital rule, we are going to differentiate this function separately, one after the other. That means the numerator separate from the denominator. Then we substitute the value of 1 as s approaches 1 then to the function, then we get our limit. So let us differentiate the function separately. 3s squared, if you differentiate s cubed, we are going to have this, we have constant 1 here, so 3 times 1 is equals to 3, then this s, then you take away 1 from this 3, we have 2, which is 3s squared. The derivative of s cubed is 3s squared, then plus, if you differentiate 2s squared, that we have constant 1 here, 2 multiplied by that 1, you have 2, this is s, then take away 1 from here is 1, so anyone raised to power and still that thing, so we are going to have 2s. So the derivative of minus 1 is 1. because this is minus s. This is s rather. We have is raised to power 1 and the coefficient is still 1. 1 multiplied by this, we have 1. This is s. Then you take away 1 from here, it will be 0. So you have 0, and anything raised to power of 0 is 1. 1 times 1 is still 1. So here now is 1. Then divided by, if you differentiate s squared like we do it, we have 2s. Differentiate 2s, you have 2 plus 2. And the derivative of a constant is 0. So the derivative of this minus 1 also is 0. So from here now, we can impute our 1 here, because s is 10 to 1, it approaches 1. So from here I can say limit s approaches 1 here. We are going to use this one now. So equal to 3 into 1 square plus 2 into 1 minus 1. Then all over, we have 2 into 1 plus 2. So from here now I can say 1 square is still 1. 3 times 1 is also 3, plus 2 times 1 is 2. Then this minus 1 is constant, all over 2 times 1 is 2, then plus 2. So from here now I can say 3. Okay, 3 plus 2 is 5. 5 minus 1 is 4. All over 2 plus 2 is 4. Then 4 divided by 4 is 1. So the limit of this function, s cubed plus s squared minus s minus 1 all over s squared plus 2s minus 3 is 1. If you are finding the limit, if you have the value is 0, the limit will not stop at that level. You are going to continue using L'Hopital rule or long division. So maybe in my next video I will teach you how to use long division to find such problem. Thanks for watching, and don't forget to subscribe to my YouTube channel. Follow my Facebook page at Chabest Online.